Okay, so for number 23, you have f of x is x squared plus 1 and g of x is x minus 4. So this is telling you to plug negative 1 into the f function and divide by what you get when you plug negative 1 into g, and then subtract what you get when you plug 3 into g. So to put negative 1 into f of x, you have negative 1 squared plus 1. Put negative 1 into g, you're going to have negative 1 minus 4. To put 3 into g, you have 3 minus 4. Alright, so negative 1 squared is 1, plus 1 is 2. Negative 1 minus 4 is negative 5. 3 minus 4 is negative 1. So this is a big plus sign, so this is 2 over negative 5 plus, and we're going to call that 5 over 5 so that they have common denominators, which gives us 3 over 5. Because this negative 5 on the bottom, you can pull that out and just say that the whole fraction is negative. Because if I had 2/5 as negative, I could write it with the negative on top or with the negative on bottom. Those are all three equivalent. So if I just move that out front, then I know that I'm taking negative 2 plus 5, and I get 3/5 for the answer. All right, 41. For f of x, you have a domain restriction that x can be anything but 0, because that's going to make you divide by 0. Here you have no domain restriction, so you can say all real numbers. If I want to do f of g, so remember that's the same thing as if you wrote it like this, which I like better because it tells me I'm plugging g into f. So my f function is 1 over something, and I replace the something with that whole g function. And so that is what f of g looks like. And then you just have to make the statement that that's the case provided that you don't use negative 3 in the place of x. Because if you use negative 3 here, you get 0 on the bottom, and we can't divide by 0. If I do g of f, then I'm plugging the f of x function into the g function. So I have something plus 3. Well, my something is 1 over x, so those parentheses I just put there to say something. You don't really need them. So 1 over x plus 3. You can leave it like that. There's no reason to clean it up. So I'll scoot this over. So that's all that you have. That's your function. And then again, you have a variable in the denominator, so you have to put the domain restriction in there. And in this case, it's just that it can't be 0. All right, so for 43 and 45, you're looking at those graphs. So let me see if I can get it to where you can see those in the book. All right, so for 43, we are doing f plus g of 3. All right, so that's f of 3 plus g of 3. That first thing that we glued in our composition book said that those are equivalent statements. So I'm going to use the graph to find f of 3. So this is f. If x is 3, then y is 2. So this is 2. On the g function, when x is 3, y is 1. So this is 1. So I get 3 as my answer. For 45, they're wanting f of g of 2. So remember that you can write that like this, which means you need to figure out g of 2 and then plug it into f. So if we figure out g of 2, here's our g function. X is 2, that means y is 2. So we figured out that g of 2 is 2. So I replaced it, and I'm going to find f of 2 now. So 2 gives me 0 as a y value. So 0 is my answer. I hope that helped. If not, then let me know and I'll see if I can make it any clearer.